how it works, the electric grid. What is electric grid? Could you please read this one at home?
At home, you lift, lip,
You flip a switch,
flip a switch, and a lig,
a light,
lig, a lig,
a light
a light,
comes on.
a light
Comes on.
comes on.
Look, Muhammad, if I ask you, Muhammad,
Comes on.
when you switch on the light, how can you switch on the light?
With that.
You will go to the switch and put it on. And by this way,
Yeah.
you light up the lamp, right? Thanks, Muhammad. Yusuf Auda, go on. The electricity.
Okay. The electricity to power the light comes from generating stations.
Wait. What is generating station? You
The
remember?
station that generates electricity.
Yeah. So how can we generate electricity?
From the generating station.
Yes, I know. Like what? Like wind? Like dams? Like waterfalls?
Wind, waterfalls,
Dams?
dams, and yeah, many more.
And many more. And also there are some stations like nuclear stations, but they are not exist in our country. Maybe in the future. Okay. So go on, read. Generating stations.
Generating stations are a part of a larger system known as the electric
It's
light.
a written mistake here. Supposed to be known as electric grid. Electric grid. Thanks. Mu'taz, go on. Generator.
Generators, high voltage steel towers.
Steel towers.
Steel towers, conductors, insulators, and your home appliances are all parts of the system.
Look, Mu'taz, I'm pretty sure that you see this picture number 2 before.
Yes.
Picture number 2.
Yes, we see it a lot, but we see it more at the desert.
Yeah, desert. Conductor, insulator, and your home appliances are all parts of this system. Okay, Mu'taz, thank you. Yusuf Hazm, the first picture.
Okay.
A generating.
Generating stations, generators transform kinetic energy into electrical energy.
What is kinetic energy, Yusuf? Yusuf?
Yes.
Kinetic energy. What is kinetic energy? You remember?
Not really.
You can say kinetic energy is energy of motion. When you push something, when you move like the fan, it's kinetic energy. Okay?
Okay.
We can change the kinetic energy to be electrical energy in the end. And that happens in generating station. In generating stations. Okay?
Okay.
Thanks. Muhammad Sultan. Picture number 2.
Yes. From the
generating stations.
Generating station, electricity,
Electrical energy
over
travels
over
electrical lines on tall steel towers.
These lines
lines are made up of a
Conductor and insulator.
and an insulator.
Thank you. Abdul Mohsen. Muhammad Sultan said these lines are made up of conductor and an insulator. What is conductor and what is insulator?
Conductor is anything that absorbs heat. Any metal that absorbs.
It's not exactly the same meaning, but let me tell you. Give me the right definition. Conductor is a material that let heat and electricity to move through it easily.
Yes.
And what is insulator?
Insulator is the opposite.
The opposite. So the material that doesn't let heat or electricity to move through it easily. Yusuf Auda, you are now 25 years old. Forget about the effects now and focus, please. Abdul Mohsen. So give me one example for conductors and one for insulator.
Metal spoon.
Metal spoon as? Got conductor or insulator? Okay. And then insulator?
Leather clothes.
Thank you. Manef, picture 3.
Yes,
Picture 3. Coal.
coal is a fossil fuel. There is plenty of it. The United States, most of our electricity comes from burning coal.
That's right. But also we can say there is plenty of it in KSA. If we talk about coal,
Yes.
and also in all Arab countries. Thank you. Faisal? Faisal?
Yes.
Wind turbines.
Wet.
Picture number 4.
Wind turbines are large generators. Turbines use energy from wind to generate electricity.
Yeah, so we can say this as generating electricity, this station for generating electricity, and this one as well from coal, this one from the wind, this one from coal. Also, we can use dams and waterfalls to generate electricity, right?
Yeah.
Thank you.
Welcome.
Abdullah?
Yes.
Troubleshooting. Read this part, please.
During
Prolonged
hot weather, many people use air conditioner and units to remain cool. How could this affect the electric grid and the environment?
Are you using AC right now, Abdullah?
No.
It's okay, the temperature?
Yes.
Okay, so how could this affect the electric grid and the environment? This is a very, very good question. Why we say the AC is bad for the environment?
Because it makes the room very cold.
The room very cold. And what is the bad effect on the environment outside your room? Look, read this. Increase electricity.
Electricity use leads to increase
pollution. You know what is pollution?
Yes.
Like the smoke, like the bed.
Yes.
Yeah.
Yes.
Okay.
There used to be less pollution.
Yes. It may also lead.
It may also lead to equipment failure within the electric grid, resulting in power outages and the blackouts.
Thank you.
You're welcome.
Now, how does the power grid work? Listen carefully.
The modern world depends on electricity. It's not just a luxury we use to power our devices and enjoy our free time. It's not even just the convenience of having light, heating, and cooling in our buildings. Electricity is a crucial resource, especially in urban areas, providing public security, safety, and health, and making possible everything from emergency response to modern medical care in hospitals to even the other utilities we require, like fresh water and sanitation systems. But unlike those other utilities, electricity can't be created, stored, and used at a later time. The instant it's produced, it's used, no matter how far away the producer is from the user. And the infrastructure that makes all this possible is one of humanity's most important and fascinating engineering achievements. Hey, I'm Grady, and this is Practical Engineering. On today's episode, we're talking about the power grid. This video is sponsored by NordVPN. Visit nordvpn.com/practicalengineering to get 75% off a 3-year plan. More on that later. Like most people, you probably take the grid for granted. Electrical infrastructure is so ubiquitous, it's easy not to notice that most of our power grid is out in the open for anyone to have a look. I happen to be one of those people who does want to have a look, and hopefully by the end of this video series on electrical infrastructure, you will be too. This video is geared toward North America, but most of the concepts will apply to any other part of the world. And just to give you a sense of scale, there are only 4 distinct electrical grids that service essentially all of North America. You have the 2 big ones, Western and Eastern, and the 2 electrical separatists, Quebec and Texas. Depending on your definition, an electrical grid can be considered one of the world's largest machines. So how does this machine work? The basic function of generating electricity and delivering it to those who need it may seem simple. I can hook up a small generator to a light and boom, power grid. With the cost of solar panels reaching record lows, many are
Ahmed? Ahmed?
Yes?
Do you know what is this thing?
Yeah, I know it. They put it there, and it's like a window, and it gains sunlight from the sun. It gets electricity from the sun.
So they are solar panels. Solar
Yeah,
panels.
solar power.
So they can
Panels.
change the sun energy to be electrical
to make
energy.
it electricity.
Perfect.
Yeah.
exploring the possibility of
Mister-
generating all the
Mister-
power they need at home.
Yes, Ahmed?
Can I show you something?
Yeah. Can you show me this later, please?
Okay.
And forgoing the grid altogether. But a wide area interconnection, that's the technical term for power grid, offers some serious advantages in exchange for increased complexity. Here's a simplified diagram showing the major components of a typical power grid, and we'll follow the flow of electrical current as it makes its way through each one. We start with generation, where the electricity is produced. There are many types of power plants, each with their own distinct advantages and disadvantages, but they all have one thing in common. They take one kind of energy and convert it into electrical energy. Most power plants are located away from populated areas, so that electricity they create needs to be efficiently transported. That's handled by high voltage transmission lines. At the plant, transformers boost the voltage to minimize losses within these lines as electricity makes its way to the areas that need it.